Hey, ladies and gents. So sad news. I recorded it and something happened. There was some sort of error that I didn't even know about till I hit stop recording. So, yay! This is the second time I've recorded this video. Hopefully it's the last time. Alright, so this is the final video in my Solving Systems of Equations series. So yeah. We're going to be graphing, we're going to be talking about classifying systems. So talking about systems of equations that can either have one solution, no solution, or infinitely many solutions. And how we can tell which one is which without having to graph it or without having to solve it. That's not to say that you can't graph or solve it, but just to save you some time, like if you notice that pattern, don't waste your time on solving it because it doesn't have a solution. So hopefully this will be a quick video and not a super lengthy video like the previous videos have been. So, all right, so I have Desmos pulled up, and we're going to talk about a system. We're going to play with some equations and see what happens. So let's say I have a system that includes the equation y equals 2x plus 4 and y equals negative 6x minus 8. All right, so let's look at this equation. Or these two, let's look at the system. So I have two equations. They have different slopes, they have different y-intercepts, they have one common solution. They have one point that they share. And that's what we're used to. So if I want to make these have no solution, I need them to not intersect. So what kind of lines don't intersect? Parallel. Parallel lines do not intersect at all. So how do I make my lines parallel lines? They have to have the same slope. So let's change this. Negative 6 to 2. If I look, they are parallel. They are not intersecting. If I zoom out, I mean, yeah, they're getting closer, but it's only because I'm zooming out. Like, they still run side by side. They are not one line. They don't cross over, like they don't overlap, like they don't, the slope doesn't change. So they're infinite, like forever, they're going to be the same distance apart. So these two lines are parallel, so they are not intersecting. So if let's see, so they have no solution. Okay, so we have two parallel lines, they have no solution because they won't touch each other. So let's think about infinitely many solutions. Or let's notice something. So we have two of the same slope, but we have two different y-intercepts. What would happen if I changed my y-intercept? Okay, so my red line disappeared. It's gone. Except that not really, like, I don't have a blue line either. If you look closely, that is, well, I don't know if that's really, if I'm zooming in on the line itself or not. Here's a blue line. Here's a red line. Actually, and if I take the red off, you see more blue. If I take the blue off, you see more red. It's a purple line. It's because it's two of the same line. So if you have the same slope and the same y-intercept, that is, that's why. Okay, I'm just trying to figure that out. If you have the same slope and the same y-intercept, that is infinitely many solutions. Because it's the same line. So if I'm looking for the intersection, well, that would be every point because they're on top of each other. Every single point is its own intersection. All right, so what if they're not in slope-intercept form? What if they're not pretty like this? What if they're in standard form? Let's do a 4x plus 3y equals 9. I'm going to go back out. Okay, and let's say I want it to have no solution or infinite solutions. Remember, the slope of something in standard form is your your negative b over a. So as long as these two numbers are the same, the number in front of x or y is the same, then your slope is the same. So we could do 4x plus 3y equals, so let's do something other than 9. If we do something other than 9, let's do 1, they're parallel. If I go with 9, they're the same line because I typed the same thing twice. Okay, but what if I don't have two of the same thing? We could do something that's equivalent. So I could, if I multiplied everything in this equation by 2, that would give me 8x plus 6y, and let's keep 9. That would give me parallel lines. But if I multiplied that 9 by 2, that would give me two of the same line. And that's okay. That's just showing me that I've got two parallel lines, or I'm sorry, two coinciding lines. Even though they look completely different, if I were to divide this by 2, if I were to divide all three terms by 2, I would get an equivalent equation. You could have fun with this. We can make this negative, negative, and negative, and they would be the same line again. So if the two equations are equivalent, it's the same line. If the two coefficients are equivalent, so the slopes would be the same, and then this number is different, then they'd be parallel. So remember, these two numbers affect the slope. This number affects the intercepts. That's going to come in handy on a particular question in just a minute. Okay, so we have, can I delete that? Okay, no. So we have parallel, we've talked about no solution and infinite solutions. So let's look at things that are one solution. One solution would, and we'll go to slope-intercept form for that, because pretty much the no solution and infinite solution have the same slope. One solution has different slopes. Everything, because they have different slopes, those lines will be angled differently, so they'll only pass each other, or they'll only cross through each other one time. So let's do y equals negative 2x plus 4, y equals 3x minus 7. And we can find their intersection point right there. But what if I change this negative 7 to positive 4? What if they have the same y-intercept and different slopes? If they have the same y-intercept and different slopes, then guess where they intersect? At the y-intercept, which means when you go to solve these algebraically or whatnot, you already know what y is. Y is going to be 4. Actually, you sure already know what x is because x should be 0. If they have the same y-intercept, their solution is the y-intercept. You shouldn't even have to work that out. Yay! Okay. So, one thing I do kind of have a sum up. So, let's see. I'm going to pull up my document camera. Actually, let's clear everything out. So let's clear everything out. Now just there we go. Okay. Let's clear everything out. So let's pull up my document camera. Actually, we'll come back to this question in a minute. So, let me zoom in on this. Maybe. Okay, it's not acting right today. There we go. All right. Okay, so just kind of to sum up, if it's one solution, the slopes of the two lines are different. If it has the same intercept, then the intercept is the solution. So, boom, we've been doing one solution forever. Like, that's all we've been working on. Now, if you've got the same slope, this is where it branches off. Same slope. If you are trying to, if you're looking for no solution, it's going to have different intercepts. So same slope, different intercepts, no solution. Same slope, same intercept, infinitely many solutions, because guess what? It's the same line. All right. So those of you that think this chart's going to be really helpful, screenshot it, jot it down, make a copy of it, go ahead and pause the video, do that. And all right. So this question, so remember how I said this is the second time I'm recording this. I answered this question as we went along, or as I went along in the video, and then the recording didn't save. So it's already worked out. But, okay. Actually, you know what? I can just rewrite it. I would rather do that than try to figure this out and try to figure out all my crazy markings. So we have a system. We have 3x plus 4y equals 12. Now this is on your Bell packet for classifying systems. This is actually a question that is on your final. Not the exact numbers. Y'all know I'm not going to give you the exact problem, although I think I probably should just to get my numbers up. But you know, I'm a decent, I'm too honest for my own good. Okay, so I have this system. Instead of a number, I have C. So this equation is asking, what can I put in for C that would make this system have infinitely many solutions? All right. So if it's infinitely many, it's going to be the same line. So I need my slope to be the same. So I need to manipulate this equation so that it would be the same as this equation. So what could I do to 3 to get negative 6x? And what could I do to 12 to get to negative 24? So I got to multiply it. I could multiply this entire top equation by negative 2, and then the two equations would be equivalent. So if I do that, that would give me negative 6. So 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. 12 times negative 2 is negative 24. So what would C have to be for these to be infinitely many solutions? C would have to be negative 8. So cool little visual I wanted to show you. Let's pull up Desmos. Let's see. Here's my infinite versus no solution. We're going to open this up. Okay. So just play with this. We have 3x plus 4y equals 12. And negative 6x plus cy equals negative 24. So if I adjust C, remember we said A and B affect the slope. So if I adjust C, it changes my slope. If I move it down to negative 8, it lies on top of itself, which is really cool. So yeah, so it lies on top of itself at negative 8. It's two of the same lines. So that would give me infinitely many solutions because that's what changes the slope. So pull this back up. My question, what number could you replace C with to make the system have infinitely many solutions? Explain how you know. We can replace it with negative 8. If we replace C with negative 8, then the two equations are equivalent. Basically, it's the same equation. We just multiplied this one by negative 2. But because we multiplied everything, both sides, by negative 2, it's basically the same equation. So we are okay here. All right, part B. Explain why, even though you can change C to any number, this system could never have no solution. Which sounds like terrible grammar, but I promise that's correct. So if we watch, as I change my C value, what do you notice? If you look at the x-intercept isn't changing. So because my x-intercept isn't changing, they're always going to have that intercept in common. That's what this number is. This is the number that both intercepts are affected by. So because we have 12 divided by 3 is 4 and negative 24 divided by negative 6 is 4, my x-intercept stays 4. So I'm not, no matter what I change my C value to, I have that intercept. Okay. If my C value, I'm sorry, if my when I say C value, I'm talking about A, B, C, not the coefficient here. If I change this number to something other than negative 24, so let's just go with negative. Let's go with negative 12, just for fun. So now, if I change that, again, my my x-intercept is the same. So if I change that, my intersection point changes. If I change my C to negative 8, now it has no solution. But I had to change this value to get no solution. So because the C values are equivalent, like my standard form C values are equivalent, or when they're equivalent, I have infinitely many solutions. When they're not equivalent, I have no solution. So why will this never have no solution? Because the two equations have a common point, their C values are equivalent. So they're always going to have a common point. They can either have all points in common or one point in common. They can't have all or none. You're either one or the other. Okay, so I'm going to end this video here. Just make sure you look at this problem in your Bell packet. It's on your final, guys. And it's an important question. That's one of the biggest questions on your final exam. I'm pretty sure there's a question similar to this on the EOC. So just, it's an important concept. It's one that stuck out in my brain. So if nothing else, you'll have one question right. All right. So I'm going to end this here. Hopefully it records this time, because I don't think I can do it a third time. I think I'd be very sad. All right. So I hope you guys have a good evening. I will talk to you soon. Have a good one.